the universe extended conclusively, encouraging altogether more first-rate. Period. After this period, it persisted to develop but at an extra sluggish price. In the cease, changing into the universe we examine in recent times. This is the inflationary hypothesis of the antique galactic blast, the maximum eminent and widely perceived hypothesis of ways the universe started out. However, for a few physicists, this head hypothesis does now not exactly painting the movement of our universe. They proposed that the universe existed before that aspect, extending on and on into the beyond, in addition to into the future. Whilst the universe is extending nowadays, it have become contracting earlier than the huge bang. In this view, the Big Bang isn't so much a bang as a leap, a second whilst the contracting universe traded paths and began out to create once more. As established by means of their speculation, the universe might also want to pass with persisted improvement, probably determined by means of a breakdown within the a long way future. Then one extra bounce. Several physicists proposed the S might be by no means ending. This disturbing situation's the norm cosmological view, in which the whole point started out with a large bang. The splendid physicist Brian Cox moreover challenges the speculation of ways matters came to be, placing ahead that something can't emerge from nothing. Adding to the stress, the James Webb Telescope has made startling revelations clashing with the idea that the large bang can be taken into consideration the beginning of the universe. These findings supply up the question. If the massive bang wasn't the begin of the universe, then what become? Could the universe subsequently begin with a bypass or something completely one of a kind? The concept that the universe had a beginning or an afternoon without a yesterday, as it turned into to start with recognized, returns to George Lemaître in 1927. At the same time as it is a much less than perfect scenario to signify that the universe probably had a beginning, that period of galactic history has little to do with the recent enormous bang that depicted our underlying universe. But special place professionals, or maybe a minority of specialists, although, remain with conviction that the huge bang marks the very beginning of the whole thing. All subjects taken into consideration, the definition is out of the large bang. Isn't the presentation of life as we might be privy to these days? In truth, there may additionally be a lot proof highlighting a non-solitary starting of our universe. We never arrived at those conclusions based totally on no evident endo or excessive temperatures. Our universe is pleasant defined via an inflationary length that happened earlier than the massive bang. The huge bang is the cease-end result of what happened in the course of the consummation of advancement. Throughout development, the universe changed into definitely void, no particles, irrespective of no photons, just void area. Place itself became packed within significant amount of energy at every vicinity. This energy changed through the years, extending in a quick and decided fashion. Due to the fact the universe extended, those adjustments loosened as much as huge extensions. Whilst new confined scale modifications have been made to top them. This superposition of instabilities across scales is a characterizing detail of cosmological extension. Its surrender for arbitrary motives, not planned. If you lived in a growing universe, you may likely come upon close by areas where an augmentation reached and stop or the area amongst you and them extended emphatically. In short, you could try and understand what takes place towards the starting of a huge impact. Before that place vanished simply from view. On the begin, it consists of a small neighborhood region, probable no more considerable than a human vast hamster ball but probable significantly bigger. The strength aspect of vicinity then gets changed over into be counted and radiation. This alteration takes place speedy, taking more or less but now not right now. Due to the fact the strength positive up in location itself adjustments over into particles, photons, and more. The temperature rapid augments from only some tiers above absolute zero to possibly around 20 Kelvin over the equal quick time body. Because of the massive diploma of energy modified, the entirety moves close to the speed of mild. All particles act as radiation with large power, whether they're massless or large. This modification is known as reheating, marking the stop of development and the start of the degree called the new large bang. As development proceeds, you'll witness a large alternate from all previous situations whilst the current huge bang starts. The expanding universe quick slows down after the hidden photo of development in an inflationary universe area expands definitively with more a protracted manner away areas going for walks unendingly. While development ends and the new huge bang begins, extra remote areas will recede from you to an ever-increasing diploma progressively as time progresses. The part of the universe in which development ends sees the extension phi drop, whilst the expanding areas surrounding it see no such drop. Underneath expansion, the gap to any item should double after a positive period. And whilst that identical amount of time elapses, that distance doubles over again indefinitely. Once the Big Bang begins, this adjustments because the increasing universe slows down after the initial second of improvement. Before the Big Bang, you can come across development cleansing off with neighboring areas. Those regions wherein development ends will fill with rely, antimatter, and radiation, and extend more slowly than the still growing regions, leaving you inside the growing nearby as a normal community within spacetime. Those regions wherein warm huge bangs rise up end up remote from extraordinary places wherein improvement maintains, which means they may rapid recede from each other's view inside the norm inflationary picture. Due to this, the improvement price changes. There may be little threat that any universes with separate warm huge bangs will ever have interaction. The location wherein we come to reside gets surprisingly lucky and increase reaches a stop. For us, the strength feature of space itself gets changed over to a warm, thick, and nearly uniform ocean of particles. With the number 1 imperfections and departures from consistency regarding the quantum changes that existed and were loosened up throughout the universe quicker or later of development. The high-quality power quantum fluctuations correspond to begin with to overdense areas, while the lousy strength fluctuations get modified over into initially underdense areas. Those feature because the seeds of big systems. We cannot see these density fluctuations these days, as they had been at the same time as the universe first of all went via the warm huge bang. There aren't any seen imprints we are able to get admission to from that early period. The number 1 observable imprint comes from spherical 380,000 years later, after going through brilliant affiliations. Although we will extrapolate again to understand the initial density fluctuations, locating something steady with the narrative of galactic improvement. The temperature fluctuations are engraved inside the cosmic microwave history, CMB, imparting proof of how the massive bang started. However, there are numerous inconsistencies some of the CMB and our current model of cosmology. We're lacking something, and people may be summarized in for inconsistencies. First, on specifically huge scales, the universe is not behaving as predicted. The light from the CMB is being lensed through depend among us and the CMB, meaning rely acts like a large lens, bending and changing the amplitude of the light in the return of it. The volume of this lensing isn't always regular with our reducing side version, representing a tremendous task for cosmology. Secondly, the two aspects of the equator of the CMB sky have one-of-a-kind commonplace temperatures, conflicting with the expectation of uniformity inside the universe's earliest degree. The belief that the universe must have commenced reliably results in severe inconsistencies. 0.33, the value of the Hubble regular, which describes how rapid the universe is expanding, modifications depending upon whether we measure it from the cosmic microwave historical past, CMB, or from neighboring stars. Together, these irregularities recommend we're lacking something important in how we interpret the universe. One proposed answer comes from loop quantum cosmology, which originates from loop quantum gravity. On this framework, gravity itself is made up of debris called quant, shaping the cloth of existence. In loop quantum cosmology, there is a smallest scale of vicinity, the Planck scale, or 1.0*10 to the power of -35 m. This way, the Big Bang could not exist in a universe defined via this principle. Instead, the universe could via no method attain an infinitely small dense factor near the Big Bang. In loop quantum cosmology, even as the universe became very small, quantum corrections anticipated a repulsive strain, inflicting a jump alternatively of a singularity. This suggests that our universe may have originated from a preceding universe that shrunk after which elevated all over again, much like a phoenix growing from the ashes. Even as the idea of a cosmic leap isn't entirely new, loop quantum cosmology gives a mathematical framework to assist it. Cyclic time, just like the idea of a cosmic leap, is additionally located in Hindu cosmology, adding further weight to this idea. If loop quantum cosmology is correct, the early universe would possibly have had a mild energy and density. This condition should adjust the CMB, acting as slight variations in temperature all through the sky. These versions, measured through the pleasant electricity spectrum, should provide large evidence of the universe's foundation and guide the possibility of a bounce universal. Loop quantum cosmology offers a compelling possibility to the state-of-the-art huge bang version, potentially resolving a number of the prolonged standing inconsistencies in cosmology and imparting insights into the origins of the universe. It additionally offers a promising motive of the third irregularity, the discrepancy in average temperatures between the two hemispheres of the CMB sky. The shape provided via manner of loop quantum cosmology addresses the number 1 anomalies located in the CMB, the uncommon conduct at large scales, and the lensing impact. According to Dr. Venet Goind of the Countrywide Institute of Advanced Research, the possibility that the one's irregularities are not just size errors but originate from quantum gravity results early within the universe is pretty. The concept that the universe started out in a cosmic leap has been proposed before, but its affirmation calls for studies. Cosmic variance poses an undertaking in this view, as our observations may be constrained to specific parts of the universe, complicating our knowledge. Dr. Dwayne Johnson, a co-author of A Giant Have a Look At and a professor at Penn State College, highlights the hassle in validating such theories due to the huge range. But the incorporation of latest possibilities like loop quantum cosmology and its implications keep promise in resolving particular cosmological issues. In spite of those enhancements, a giant query remains. Did the universe have a beginning at all? Proponents of the universe having a beginning insist that it did, but this increases questions about the character of the event that started out the whole lot. Conversely, cyclic cosmology proposes an everlasting universe, continuously present system cosmic bounces. But physicist William Kenny of the University at Buffalo identifies a fundamental flaw in this concept: entropy. The diploma of disorder in a tool will increase with each cosmic jump to a non-stop depletion of usable strength. This entropy growth implies a starting like a massive bang, conflicting with the concept of an eternal universe. Whilst new cyclic fashions try to cope with this trouble by way of along with expansive ranges among bounces to burn up entropy, Kenny's research advocate that the universe in all likelihood had an absolutely unique beginning. Kenny's findings highlight the continued debate over cyclic universes, prompting in addition investigation into their feasibility. Proponents of cyclic universes haven't begun to absolutely deal with this criticism. The scientific communicate approximately this difficulty consider keeps to conform, pushed with the aid of the hunt to determine the universe's origins and its final destiny. Quantum cosmology and cyclic fashions, which suggest numerous mechanisms to deal with anomalies, have sparked hobby among cosmologists. Nelson dos Santos of the Brazilian Countrywide Institute for Space Studies, who has delved into bouncing and cyclic models, notes that whilst loop quantum cosmology bounces cope with CMB anomalies, they may not be useful nonetheless. He stays confident in the possibility of a cyclic universe. In maintaining with Nelson, the life of the universe is tremendous, creating a cyclic universe constantly present appear extra viable than one created at a unique moment. As a scientist, he stays open to exploring each possibility. Whilst the start of our universe stays a mystery, there has been extreme speak about its very last future. The future of the universe is predicated upon its composition, which consists of darkish electricity and figuring out its fate. Basically, there are fundamental situations: infinite enlargement or contraction. In one situation, the universe expands indefinitely, with stars finally laborious their fuel, leaving behind stellar remnants like white dwarfs and black holes. But the destiny of the universe is based upon the character of dark electricity, a mysterious pressure driving the universe's increase. If dark power remains constant, the universe enlargement accelerates to a cold darkish big freeze as remember disperses and entropy will increase. Instead, if there may be sufficient the universe's increase might also sluggish and contrary into contraction. This scenario ends in the possibility of a cyclic universe model, where the universe undergoes cycles of growth and contraction, never achieving infinite density or a particular starting. Every cycle marks the begin of a brand new generation of existence, presenting a more reassuring attitude in comparison to a cold darkish demise. No matter the universe's destiny, our presence at this unique moment is notable. It suggests our precise role inside the universe and the essential function of knowledge in considering the universe's vastness and its inevitable reality. As we ponder the universe's nature, we're forced to endure in mind the meaning of our life and the brief nature of time itself. Thanks for taking note of this episode. Your guide drives us to supply high-quality content material fabric, and we appreciate your comments on modern subjects. Stay tuned for Destiny episodes by subscribing and spreading the phrase. Until next time, hold exploring the mysteries of the universe. In the quest to unravel the mysteries of the universe, scientists delve deeper into the complexities of cosmology, probing the origins and ultimate fate of existence itself. With each discovery and theory proposed, new avenues of exploration open up, challenging existing paradigms and pushing the boundaries of human understanding. One of the most intriguing aspects of cosmology is the concept of multiverses, which posits the existence of multiple universes beyond our own. These parallel realities may have different physical laws, constants, and even dimensions, leading to a staggering array of possible universes. While the existence of multiverses remains speculative, it offers a tantalizing glimpse into the vastness of cosmic possibilities. Another area of active research is the nature of dark matter and dark energy, which together constitute the vast majority of the universe's mass energy content. Despite their profound influence on cosmic evolution, these enigmatic substances elude direct detection and comprehension. Understanding the properties of dark matter and dark energy is crucial for unraveling the underlying structure and dynamics of the universe. Furthermore, advancements in observational astronomy and computational simulations have revolutionized our understanding of cosmic phenomena, from the formation of galaxies to the evolution of black holes. High-resolution telescopes like the James Webb Space Telescope promise to unveil unprecedented insights into the early universe, shedding light on its formative stages and primordial structures. Moreover, interdisciplinary collaborations between physicists, astronomers, and mathematicians continue to drive progress in cosmology, fostering innovative approaches and novel perspectives on fundamental questions. From string theory to quantum gravity, from cosmic inflation to quantum fluctuations, the quest to reconcile quantum mechanics with general relativity remains one of the most profound challenges in modern physics. As our understanding of the cosmos deepens, so too does our appreciation of its beauty, complexity, and sheer magnificence. From the cosmic dance of galaxies to the intricate patterns of cosmic microwave background radiation, the universe presents a breathtaking tapestry of phenomena waiting to be explored. In the grand tapestry of existence, each discovery, each theory, and each question posed adds another thread to the fabric of cosmic knowledge. As we journey further into the unknown, guided by curiosity and fueled by the quest for truth, we embark on a timeless odyssey of exploration, discovery, and wonder. So let us continue to gaze into the depths of space, to ponder the mysteries of time, and to marvel at the wonders of the universe. For in our pursuit of understanding, we find not only answers but also new questions, beckoning us ever onward on our cosmic voyage.